Salts can have acidic and basic properties. Some salts are neutral, others are acidic, others are basic. The rule of thumb is if the acid is strong and the base is strong, that results in a neutral solution. Now, if the acid is weak but the base is strong, that results in a basic solution. If the acid is strong and the base is weak, that results in an acidic solution. And if they're both weak acid and weak base, it varies. So we can predict the acidity or basicity of acids and bases, or the salts of acids and bases. The first one is magnesium chloride. This is a salt that formed from a neutralization reaction. Let's look at the reaction that would form this. So if we back up, we may have had a reaction that looked like this. HCl plus magnesium hydroxide. So it's possible that this reaction formed this. Now, this reaction would cause neutralization. The hydroxide and the hydrogen would come together, and that would produce water, H2O. Now, what's left over, the chloride ion and the magnesium ion, those would come together to make the salt Mg, magnesium chloride, MgCl2. You would have to balance this equation. I believe if we just put a 2 there, there's 2 hydrogens, 2 chlorines, and that should balance the equation. So 2 over here, 2 there. We'll need a 2 on this side as well. 2 oxygens. Okay. So this is the reaction that made the magnesium chloride that we're looking at here. So the magnesium chloride is coming from a reaction like this, a neutralization reaction. And so in that neutralization reaction, an acid reacted with a base to make the salt. And so our question now is this a salt acidic or basic? Because some can be acidic, some can be basic, and some are neutral. Could also be neutral. Well, the way of predicting this is we need to know whether the acid is strong. So if acid are therefore out that this is strong base. The ions, the chlorine and the magnesium, those are neutral. Now, so we'll be using this table from our textbook. We're looking at the ion, the chloride, and here it comes from a strong, comes from a strong base. And so if they both come from a strong acid and a strong base, that means that it is, so from strong base and from strong acid. So this is neutral. So it's kind of like what we've seen earlier, that when we have a relationship here between acid and base, where strong acids have weak conjugate bases. And likewise then, weak acids have strong conjugate bases. So based on this relationship, if they both acids are from strong bases, the ion that came from a strong acid, now if that was to function as a base, it would be very weak. So the chloride came from a strong acid. Now the chloride ion minus is very weak. It doesn't do anything. It does not have acidic or basic properties. Likewise, since the magnesium came from a strong base, the conjugate of that, the weak Mg2 plus ion, does not have acidic properties. It's very weak. And so the solution then is neutral. Let's try another example. So we have NH4NO3, ammonium nitrate. So we can look at the ions that exist here. And so ammonium came from, ammonium came from a weak base. We can see on here, ammonium comes from a weak base. And then the nitrate comes from a strong acid. So the ammonium, that's from a weak base, and the nitrate is from a strong acid. So first off, we might predict that based on rule of thumb, weak base plus strong acid, weak base, strong acid, we would predict that it's acidic. But we need to understand why. So the nitrate that comes from a strong acid, if we think about this relationship, nitrate comes from a strong acid, so its conjugate is very weak. So the nitrate ion that's left over after nitric acid is very weak. It does things. We discussed analogies. It's kind of like sprinters. They have a lot of strength for a short distance, but they're done. Nothing left over. But the ammonium came from a weak base, and so if the base is weak, the acid still has some potential, the conjugate acid. So if it comes from something here that's in the middle, it's a weak base, the conjugate acid still has some potential. Back to the analogy, it's kind of like a long distance runner. They may not start off as quickly as, say, a sprinter or be able to go as quick for the short distance, but they still have some potential to keep going, to keep doing things. So since the ammonium comes from a weak base, it has the potential, the conjugate left from the weak base, which is this ion here, NH4+, has potential. Remember, there's an opposite relationship. So now, it came from a base, but now it's the conjugate acid. This is the conjugate acid. Ammonium ion is the conjugate acid that came from that weak base. Remember the opposite relationship that happens. What was the base, let's flip back a couple pages. What was the base is now the conjugate acid. and what was the acid is now the conjugate base. So we have this relationship that we've seen before as introduced the Bronsted-Lowry theory of acids and bases. So this is a conjugate acid now, and it has potential water to form. Protons going to this direction, forms, and so ammonia is weak, hydronium is stronger. This hydronium gives it acidic property. So that would lower the pH, make the pH acidic. So we have an acidic salt since it came from a weak base, strong acid. Next problem is sodium carbonate. So in this problem, we can identify sodium as one of the ions, and that comes from a strong base. Sodium is right there. Carbonate comes from a weak acid. So this is from a strong base, and the carbonate is from a weak acid. So the thing that was strong, it's done. Its conjugate is done. But the weak acid, the conjugate from the weak acid, still has potential. So this carbonate, its conjugate base now the conjugate base from the original weak acid is CO3 2-. That has the potential to have basic properties as it reacts with water. And so water donates the hydrogen ion, and we get HCO3- bicarbonate and OH-. So this hydroxide means that this salt is a basic salt. It has basic properties. So again, we see our rule of thumb demonstrated, that if something comes from a here we have a strong base and a weak acid. So strong base, weak acid, we have basic properties. One more example was given in class. If we had this salt, K2S, you might want to work that one out on your own. And I'll put the solution up right now. So here's the solution for that. We have a strong base, the potassium. Sulfur came from a weak acid, the sulfide ion. Therefore it's basic. Sulfide reacts with water to make HS and hydroxide.